Okay, dear students, now we are going to do some questions on chapter 2. So we have done a lot of tutors in chapter 1. So right now we are going to see how we can solve some problems related to chapter 2. And in chapter 2 we are going to discuss about real and complex number system. So we do have two systems here, real and complex number systems. So tutorial questions are prepared from this. So we are going to see how we can solve some problems related to this. So when we begin from the first one, you see we have here that chapter 1, and chapter 1 is in chapter 1 we have question number 1, and in question number 1 we have LCM and GCF of these numbers. So you are given three numbers, 600, 1260 and 420. So you are supposed to find the least common multiple and the greatest common factor for these three numbers, 600, 1260 and 420. So in order to find this, we need to have a prime factorization of these numbers. So let you see how I'm going to do. So we need to factorize all these three numbers. We need to look for prime factorization of them. So as you see here, prime factorization of 600 is done. So to the right side, you see if you divide 600 by 2, you do have 300 times, and 300 divided by 2, you have 150, and 150 divided by 2, you have 75. And this number is divisible by 3 because the sum is 12, so it can be divided by 3. So 75 by 3, it's going to be 25. But now we are unable to divide this by 3, so we need to divide it by 5. So dividing 25 by 5, we do have 5 times. So at last we need to divide 5 by 5 again, then we do have 1. So look here, this 600 now is written as, sorry, here this has to be 6, it is not 300, so please correct this one, dear students. This 600 is going to be 2 times 2 times 2, which actually is 8 times 3, 24, times 5 times 5, 25. This makes 600. So we can have here 600 as a prime factorized form, like 2 cubed times 3 times 5 square. Do the same for the other two, 1260 and 420. So they are done as can be shown here. 1260, if you do apply same procedure, you can obtain the prime factorization of that to be 2 squared times 3 squared times 5 times 7, and do the same for 420. And as you are doing that, you will obtain the prime factorization of 420 as 2 squared times 3 times 5 times 7. Now, dear students, as you see, all the three numbers prime factorizations are written. So the next task is a matter of looking for this LCM and GCF. So how are we going to find these two? So the GCF of these three different numbers can be obtained as you see. What you need to do in the GCF is you have to first identify the common prime factors. So as you see, the common prime factors are, as can be shown here, 2. Look, 2 is available throughout all these numbers. 3 is again here, so it's available throughout all these, and 5 is also available, so you need to select 2, 3, 5. And next from that, what you need to do is you have, in case you do have, you see different exponents, try to select the smallest exponent. Basically here we are having two exponents, 2 and 3, so the smaller one is 2, so you need to take 2 here, you see. And you have another, for instance, you need to compare all, you see, the exponents, and you need to select the least one, so the smallest one. So you do have 2 square here times, now again come here, even though it's not written, it's understood there is power 1 here, and here it is 3 square, here we have power 1, so we do have 1 and 2 as exponents, so we need to select the smaller one. So it's going to be 3, and coming here, look, we have 5 written 3 times as you see, and we do have exponents 1 and 2, so the smaller is 1, so we need to have 5 here. Look here, students, in 1260 and 420, 7 is available, but this number is not available in the case of 600, so this 7 is not the common prime factor for these three, so in the GCF it is discarded, it will never be taken into account. So look, 2 square makes 4, 4 times 3 is 12, 12 times 5 is 60. So the greatest common factor for these three numbers is going to be 60. Now the question is, how about the LCM, the least common multiple? The least common multiple of these three numbers can be obtained like this. What we need to do is we have to select all the prime factors of these numbers. Look here, we do have 2, it is written 3 times, so we need to have 1, 2 here. Then 3, so select 3 again, select 5 as you see here. Unlike the GCF where we discarded 7, now 7 is going to be considered in the case of LCM. And then when you come to the exponents, you have to select the largest one. Look, in the case of GCF, you are selecting the smallest, but now you need to select the largest one. So 3 is the greatest compared to number 2, so you need to take 3. And again here, even though you are having 1, you see here and here, 2 is the largest one, so you need to take 2. You do the same for 5, 2. Now look, 7, even if it's not available here, it is selected here, so take that as it is. So the next task is a matter of multiplying all this. This is 8 and this is 9. This is 27 times 7, and when you multiply all this, you do have 19,600. So from this you can understand that the LCM is 9,600. So it is in this way that you need to do whenever you are asked to find least LCM and GCF of arbitrary three numbers. I hope you have understood this one. Next from this we have another question. Look, question number 2 says you are given the GCF of two numbers to be 12 and their LCM is 1600. Now if one of the numbers is 600, the question is, what about the second one? Look, it is expected that, you see, we have two numbers here, but one of these two numbers is already given, it is 600. And the other two given conditions are, you see, the GCF and the LCM. The GCF of the two is given to be 12 and their LCM is 1600. So the question is how we can find the second number. You see, the question is to find or to determine the second number. So how can we do that? There is one thing that you students must know here, and that is this one. You see, for whatever two natural numbers you may take, a and b, the product of, look here students, the product of their GCF and LCM. The product of their GCF and LCM makes the product of the two numbers. So this is a governing one. So we are going to apply this one in order to calculate this. So the GCF of a and b times the LCM of a and b makes the product of the two. So consider, you see, the given one, the first one to be 600. Now we are looking for the second one, which is b. So make a to be 600, okay, in your assumption. So if a is 600, then our interest is to determine b, because you are asked to find the second one. So it is b that's going to be looked for. So next from this, you see, you just have, you see the one that is available here. So the GCF of AB times the LCM of AB, look, the greatest common factor GCF is already given, it is 12. The least common multiple is already given again, 1600. So the A is already determined, one of the two numbers is given, 600. So this is going to be 600 times B. So in order to determine what B is, a matter of dividing the whole by 600. So as you are doing this, look, B is equal to 12 times 1600 divided by what? 600. So as you are simplifying this, look, two zeros can be cancelled by two zeros here. So by 6 1, by 6 2, then 2 times 16 makes 32. So clearly one can understand that the other number is 32. You see? Now is there any other shortcut in order to obtain this one, or is there an option of, you see, assuring what we did is right or not? Yeah, basically we do have it is again just applying this one. What is the GCF? The GCF is already known, it's 12, and the LCM is already given, it is 1600. So try to multiply these two, 12 and 1600, and that has to be equal to, you see, is the product of the two numbers, that is 632. So the product of 632 must agree with the product of 12 and 1600. So in such a way we can assure, you see, whether what we obtained is right or not. So the second number, the one we were looking for, is obtained now, it is 32. I hope you have understood the basic concept of this GCF and LCM.